Hi again everyone, Chris Tisdell here again. In this presentation, I'm going to continue my series of videos on vectors. In particular, I'm going to discuss an example that shows you how to calculate the equation of a plane when given 3 points. So let me share my screen with you and we'll get down to business. Okay, so here's the question that I want to look at. We're given 3 points in three-dimensional space, A, B, and C. And we're asked to determine a parametric vector form of the plane P that passes through A, B, and C. And then write down two non-zero and non-parallel vectors that are parallel to the plane P. Okay, now just a side note before I start. 3 points is enough to give us the equation of a plane. Okay, now you might think back to basic geometry of lines, right? If we have 2 points, then we're able to calculate the equation of basic lines. Okay, so if we got 1 dimension, planes are 2-dimensional things, you would expect 3 points would be enough to give you the equation of the plane. Okay, so how do we actually determine an equation of the plane? Well, let me just refresh your memory. Here's our discussion from previous videos on the equations of planes and the parametric vector form, okay? So this parametric vector form here involves 3 things. It involves a point on the plane and 2 vectors that are parallel or contained within the plane. If I can calculate those 3 things, then this is the equation. Okay, well, lambda 1 and lambda 2 here are known as parameters. So let me just draw a quick sketch of what's going on with this question. Okay, so let's say here's the plane. All right. We know of a point A and a point B and a point C. Now there's no scale here, I'm just sort of drawing in any 3 old points. These 3 points all lie on the plane P. Okay, so what I can do then is say compute the vector from A to B, the vector from A to C. That gives me 2 vectors that lie within the plane. So they've got to be parallel to the plane. We also know that A or B, or A and B and C lie on the plane. So I can just choose, say, A as my point on the plane. Okay, and say the origin, I don't know, the origin might be down here or something. So that's what I'm going to do. I can just calculate these 2 vectors, use any of these points as my point on the plane, and once I have that, I can use this to write down a parametric vector form. Okay, so let's work through it. So 2 vectors that are parallel to the plane P are AB and AC. Now you don't have to choose those 2 vectors. You could compute, say, AB and BC. Okay, a point on P is A or B or C, whichever one you like. So let's work these 2 vectors out and then we'll be ready to write down our parametric vector form of the plane P. All right, so how do we work out the vector from one point to another point? We just use position vectors, right? So the position vector of the point B is just usually denoted by this lowercase vector, and the same with A. What I mean by that is the vector OB and the vector OA from the origin to B, from the origin to A. Okay, so to write down these vectors, I just take the points and write them as column vectors. Okay, so OB would be 3, 2, 1 written as a column. OA would be 1, 2, 5 written as a column, and to take one away from the other, you just work in a component-wise fashion. So 3 minus 1 gives you the first component, 2 minus 2 gives you the second component, and 1 minus 5 gives you the third component. Okay, so that's that done. Let's compute the vector from A to C. That's just the position vector of C minus the position vector of A. So that's OC minus OA. You don't have to write both of these things in, by the way. I'm just doing it to give you a feel for different kinds of notation. Okay, OC is just the point C written as a column. OA is just that written as a column. And with two vectors, again, just perform the operations in a component-wise fashion. So -2 minus 1, -3, 1 minus 2, -1, 0 minus 5, -5. Okay. So a parametric vector form for the plane P is this. Okay. Oops, plus. Okay, and in our case, let's say V1's this vector, V2 is this vector, because they're the two vectors that are parallel to the plane. And let's use this as A, okay, the position vector of A. So for our plane, it'll be 1, 2, 5 plus lambda 1 bracket V1. So let's just say, it doesn't matter which one you choose, let's just choose this one. 2, 0, -4 plus lambda 2 times the other vector that we calculated. -3, -1, -5. Okay, and we want the whole plane, so lambda 1 and lambda 2 range over the real numbers. Okay, so let me just make that quite clear. And there we have it. Okay, now, like as I said before, the second part of the question really is contained in the first part, because once we have this parametric vector form, I immediately know that these two vectors are the two vectors that are parallel to the plane. Okay, we just check that's a non-zero vector, that's a non-zero vector because they don't have all zeros, and just the other check is, can I are they non-parallel? Can I make that vector just by multiplying that by some number, or vice versa? And the answer is no. Okay, so let's finish off the question to non-zero and non-parallel vectors that are jointly parallel to the plane P are 2, 0, -4 and -3, -1, -5. Okay, so that's it. Probably the hardest part of this question was knowing where to start. And if you just draw a simple diagram, you can kind of see, okay, well, if we know 3 points, the vectors connecting any of those 2 points are going to be parallel or contained within the plane. Okay, so that's my example. Hope you enjoyed it. In forthcoming videos, I'm going to talk a little bit more about vectors, and in particular, we're going to discover how to multiply two vectors together. A good question is, what would that even mean, and how would it be useful? So please join me for those forthcoming presentations. If you have any comments, any feedback, put them in the comment section, and I look forward to your feedback and your company for the next time I present another video giving a gentle introduction to vectors. Please join me then.